Welcome to today's class. In last class, we discussed about mutually exclusive events where we said two events can happen but not simultaneously because they are mutually exclusive. In this class, we shall be discussing about events that are independent. So, how do we define this event? Independent events are events which have no effect on each other. In such cases, the separate probabilities are multiplied to give the combined probability. If you can remember very well, in the last video class where we discussed mutually exclusive events, we said we use the addition law there, and the common word we use there is the or. We use the or the either or. Or in this class, we'll be discussing the major word, which is the and. So, hence we use the product law. Now, what does this product law say? It says that if events A, B, C are independent, the probability of A, B, and C and so on happening is the product of the individual probabilities, that is P of A, P of B, P of C. I believe that's clear. So we multiply the probabilities together to get the combined probability. So we don't add in independent event. How do we know that this event is independent or mutually exclusive? If it's independent, you have the word and or the word both. But in the previous class, we made use of the word or. So note, use the product law to solve problems that contains the words and or both, then and. Okay, quickly let's take one example. Let's take the coin and die example. Example 1 says a coin is tossed and a die is then thrown. What is the probability of getting a head and a perfect square? Now, I told you that a coin has two sides. That part where they drew a man's shape is called the head. The other part where they inscribe the Nigerian coat of arms is called the tail. Okay, so now you remember what the coin is, and the die used to play your Ludo. Of course, having a sample space of 1, 2, 3, 4, 5, and 6. 6 sample space. Now, so they ask us to find the probability of getting either either a head or a perfect square. No, and a perfect square. You can see the word and, not or. If it was or, we add, but because it's and, we do what? We multiply. Now, solution. What is the probability of getting a head first? If you toss a coin, sample space is what? 2. To get the head is 1 out of 2, so that's 1 over 2. Now, for perfect square, if you toss a coin, if you throw a die, now the perfect squares are just 2, which is 1 and 4. Now, what is a perfect square? Any number that have a whole number square root is a perfect square. Like 4 has 2 as a square root. Can you see that 1 has 1 as a square root, but 6 is not a perfect square because the square root of 6 is not a whole number. Alright, so we have 2 out of 6. Therefore, we have 2 over 6 as the probability of having a perfect square, which if you equal to the lowest term, you have 1 over 3. Okay, so the probability of having a head and, underline the word and, a head and a perfect square is 1 over 2 times 1 over 3. And that gives us what? 1 times 1, 1. 2 times 3, 6. That is 1 over 6. I believe that is clear. Alright, so let's quickly take example 2. It says a bag contains 3 black balls and 2 white balls. Hey, a ball, okay, if a ball is taken from the bag and then replaced, a second ball is chosen, what is the probability that? Now, in this experiment, a ball is taken from the bag and then replaced. Then a second ball is chosen again. What is the probability that they are both black balls? Now, that is, we have to find the probability of picking a black ball and a black ball. Can you see that? Once you see both, it means and this and that. So you have to find the probability of picking a black ball, which is what? 3 out of 5, because we have 5 balls in the bag and we have 3 black balls, so that's 3 over 5. Can you see that? Then if you pick another black ball again, that is 3 out of 5, because after picking the first one, we return it back, then we pick on that one again and it's black, so that is what? 3 out of 5 and 3 out of 5. That's 3 over 5 times 3 over 5, and that gives us 9 over 25. That's clear. Example 2, okay. I says, what is the property that what? The property that one is black and one is white. So can you see? Probability of picking one black and one white. So we use probability of, now if you pick one black and one white, it could be in any order. It could be that the first you pick is black and you pick a white, or you pick a white first before you pick a black. So it could be in any order. And whenever you see black and white, it could be black and white or white and black. Do you understand? So probability of picking a black and a white is what? How many blacks do we have? 3/5. How many white do you have? 2. That's 2/5. So that's 3/5 times 2/5. Now you consider or p of black and white, or means plus. So now add it plus. Now for white and black, that's 2/5 times 3/5. Can you see that? So probability of black and white plus white and black gives us, that's 3 times 2, 6/25 plus 6/25, and that gives us what? 12/25. I believe that's clear. Now for I, we have probability of at least one is black. Probability of at least one is black. When you hear the word at least, for instance, if you are told that to pass an examination you must at least score 60/100, it means you can score 60 and above. If you score 70, you pass. If you score 80, you pass. But if you score 50, you fail, because it is at least means that number given and above. So the probability of picking at least one black means either you pick one black and one white, or black. So it means probability of picking one black or the both are blacks. Do you understand? Good. So what is the probability of picking one black? That is black and white, or white and black. Then black. We've solved for black and white and black in number 2. So just pick your answer, which is what? 12/25 plus what is black. That was number 1 solution, 9/25, because it is all. So we add together, and that gives us 21/25. That's 21/25. All right. So the next one says the probability of picking at most, or probably that at most one is black. When you hear at most, if I say in an exam, to pass this exam, you must at most score 60. It means you must score 60 below. At most means the maximum you can score is 60. So if you score above 60, you fail. Do you understand? That's just the meaning. So at most one is black means either one is black or none is black. Unlike at least, either one is black or they are both black. But here, one is black or none is black. Now if one is black, that's black white or white black, or none is black, white, because 2 both are chosen, so it must be white. So you've done one black and one white in number 2. Now we got what? 12/25. So you're gonna add it to what? White. That's 2/5. Can you see? Times 2/5, because the probability of white is 2/5. So multiply 2/5 in white and white times 2/5. That gives us what? 4/5. But for here, white and black is 6/5. Here, black and white, same thing. So when you add all this together, you should arrive at 16/25. I believe this class is clear. Alright, so let's quickly look into our evaluation, which we're going to do. A box contains 5 blue balls, 3 green balls. A ball is chosen from the box and then replaced. A second ball is chosen. What is the probability that they are both blue? One blue and one is green. At least one is blue, just like what we did. So please solve them. Now look at this general evaluation. It is a question on without replacement. Now the question can say with replacement or without replacement. If it is with replacement, the sample space does not change. But if you say without replacement, means the sample space will decrease by 1. Okay, let's take our general evaluation. It says a box contains 10 marbles, 7 of which are black and 3 are red. 3 marbles are drawn, one after the other without replacement. Find the probability of choosing one red, one black, and one red marble in that order. Now, when you hear in that order, you don't say either red, black, red, or one red black. No, when you see in that order, it means you can't reiterate, you can't rearrange. No arrangement is involved. So don't forget, without replacement. So after picking one red marble, which is what? How many red marbles do we have there? 3 are red. That's 3/10 if you pick the first red. If you pick one black, we still have 7 black. That's 7/9 because we did not replace it. 7/9 times, because it's and. Now times one red again. Now you have picked one red before, so it's remaining 6 red. 6/8. So your sample space will reduce from 10 to 9 to 8. Do you understand? Alright, so 2 black marbles. 2 black. If you pick the first black, don't forget that you are going to pick 3 balls. That means you pick the first one that is black. That's if you say 2 are black, that means black red, black red black, or red black black. So that's 3 iterations. Just find one, then times 3. Do you understand? When you hear 2 black marbles, that's without replacement. The first one is black. How many black do we have? We have 7 black. That's 7/10. If you are going with black red, 7/10 times 6/10. Over 9. Sorry, then times 5/8. 2 black marbles. Do you understand? Alright, so I believe you can solve the rest that way. Alright, so this is a weekend assignment and your theory. Make sure you are able to do everything and submit. I hope the class is clear. Thank you and do have a nice time.